Okay, so this is my 2.09 discussion-based assessment. And question 1 asks, how do rigid motions affect a given figure? So basically, a rigid motion is when an object gets moved and it still maintains its original shape. So let's say we're looking at this square. Wait, no, that's a rectangle. And we're going to reflect it across the y-axis. Wait. So let's reflect it. Okay, after we've reflected it across the y-axis and you look at all the sides, you can see that they're all the same. So this would be considered a rigid motion. And an example of that in real life could be when you're driving a car, and every time you move your car, like say from home to school, it maintains its original shape. Well, unless if you crash it, of course. But it would be considered a rigid motion. So, question number 2, how can a sequence of transformations map a figure onto itself? So, let's say we have this square, and, oh wait, I need to draw another square. So, we could do a transformation. We could do the transformation 8 and -4, so increasing 8 on the x and decreasing 4 on the y, and then we will get this square. And then to map this figure back onto itself, we would need to do a 180 rotation around the origin, which is 0, 0. And the formula for that would be -x, -y. So this point right here would be 4, -1. And if we plug it into this formula, we would get, wait, -4 and +1, which is this point right here. So, on to question 3. What does it mean for two shapes to be congruent? So, two shapes are congruent when they are the same shape and their dimensions are the same. An example of this in real life could be when you have two pencils, and since they are the same object and have the same dimensions, they would be congruent. But they wouldn't be congruent even if they were the same object, but one was shorter than the other. And that concludes question 3. And this has been my 2.09 discussion-based assessment.